Determinants and Cramer's rule. So determinants and Cramer's rule, we're not going to look at both of them today, but they do go together because Cramer's rule revolves around being able to do determinants. Now the first thing we're looking at is a second order determinant. The value of a second order determinant is the difference of the product of the two diagonals. The difference of the product of the two diagonals. Let's get a highlighter. So really what we're looking at is A times B minus B times C, our diagonals. 4 times 5 minus 5 times negative 3 is the difference of our two diagonals. So if we look at this first one here, let's just go on and look at an example because it's going to be a little bit easier if we look at actual numbers and work the problem out than it is to sometimes look at the definition itself. So if we look at this here, well, our first diagonal would be 5 times 9. And we're going to subtract from it what? Negative 4 times 8. Well, 5 times 9 is, and we're going to subtract from it what? Negative and negative really make a and that's it. Now, with most matrices and stuff we can do with a matrix, we could plug this into the calculator. But why? I mean, these here, realistically, I think you can do them almost 2, if not 3 times over before you even fully get it typed into the calculator. There's not a whole lot of reason to do these in the calculator. Because if we look at the next one, our one diagonal going from the left to the right would be minus 6 times 4.
Will the top right always be before the bottom?
Because we're going to go top. So we're going to go left to right first, subtract it from, so left to right, subtract it from right to left. Well, 0 times negative 11 is 0. That's just 0. Negative 6 times 4 is. And I mean, realistically, we could have typed the whole thing into the calculator. 5 times 9 minus negative 4 times 8, hit enter, and we have our answer. Let's look at 1A. Well, what would we do? Negative 6 times. Well, negative 6 times 8 is negative minus. Well, negative and negative would make a positive. Wouldn't be 20. Unless I misheard you. 22. Yeah. And it would be 22. Last one, we would have what? Times minus 5 times 9 or 9 times 5. 7 times negative 4 would be negative 28. 5 times 9 is, would give us negative 2. And that's it. Questions on these here? Now these here are all the steps and the processes to do a determinant for this one here, for a 3 by 3. Now, whenever we take the determinant, it has to be a square matrix. It has to be a square matrix for us to take the determinant. Now, whenever we evaluate these here, the determinant of a 3 by 3, we're still going to use the diagonals. I'm going to go on and grab a highlighter for this. So we would do the diagonal of this here. Let's get a little bit skinny for this highlighter. We would do this diagonal, and then we would have to curl around for the second one, and we would have to curl around for the third because we're still getting all the way across. Now, first I'm going to do is not do that. I'm going to rewrite this determinant. 4, negative 3, negative 4. Negative 8, 2, 5. 3, 6, 9. 4, negative 3, negative 4. Negative 8, 2, 5. And what I want to do is I want to rewrite the first two columns next to it. Because what this is going to do is going to make it easier for us to see the diagonals that we're going to have to multiply together. So, let me get my highlighter back out. Because this here is 4, this would be our first diagonal. This would be our next one, and this would be our third. So really, our first diagonal that we have would be 4 times 2 times 9. So we're still kind of doing the same thing, but we just have it bigger. And for us to really be able to see it, we really needed to add those first two columns onto the end so that we can see the nice diagonal lines. Now our next one would be negative 8, 6, and the last one would be times 5. Yes. So these are all the ones going from the left to the right. Now we would also have all the ones going from the right to the left, but before we start calculating those up and writing them down, let's go on and just finish off the calculations for this side here. So the first one we'll have is 4 times 2 times 9. Then we would have negative 8 times 6 times negative 4, which will be positive 192. And 3 times negative 3 times 5 is negative. And we add all those together. Because the value of all the ones going from the right to the left, we will combine together. And if we add all of these together, we get, it's going to be 200 something. $219. Any questions on this so far? And now we need to go the other direction. Let me get the highlighter back out. Because now we can start, let's go with light blue. Top right, and this here would be our first diagonal because we're going 3, then our next one would be here, and our last one would be here. So our numbers would be negative 8 times negative 3 times 9. And we would have 4 times 6 times 5. And 3 times 2 times negative 4. And again, just like we did on the ones going from the left to the right, we're going to multiply these together and then combine them. So negative 8 times negative 3 times 9 is going to give us a positive number. 4 times 6 times 5 is 120. And 3 times 2 times negative 4, negative 24. And then we would add those three together. Because again, like with the second order determinants, we took the diagonals going from the left to the right and subtracted from it the ones going from the right to the left. We're going to do the same thing here. Is what? 3. So really in the end, what are we taking? 219 minus 312, which is negative. So the determinant of this matrix is negative 93. Any questions on this here? Would it be faster to type these in? Yeah. When we're taking the determinant of a 3 by 3 or higher, so 4 by 4, 5 by 5 of these square matrices, it's a little bit easier to type it in because the calculations for 3 by 3 are actually not difficult, just tedious. It just takes a lot of time to calculate them out. Let's do the next one in the calculator. Let's do the next one in the calculator. So that y'all can see how it's done and we've done one together. So if for 2a, if we want to find a determinant, well, the first thing we need to do is actually plug it into the calculator, the matrix. So to pull up the matrix, we can go second matrix and over to edit and hit enter, yes? And we'll want to type that matrix in. I've already got it typed in because we did this one last hour, so. Any questions on how we type the matrix in or get to this form? We good with this here? Yes. Because once we get the matrix typed in, we can go second quit. Now, to do a determinant, we're going to go second matrix. We'd go over to math. Then we need to find determinant. That's the first one, DET would be determinant. So I can hit enter to call it up. Now, if you hit enter again, it's going to say error because we haven't told it to what to take the determinant of. But we can go second matrix. And I can call it matrix A. And then hit enter. And it'll tell me that the answer is negative 48. Because the determinant of a matrix will be just a number. Any questions on this here? We good with this here? All right. Now, really that's all we have for today because I'm going to cover Cramer's rule tomorrow. And Cramer's rule is taking determinants and using them to solve systems of equations. It's not the most effective way to solve systems with matrices. We'll cover that on Thursday and Friday. Really Friday most likely is when we'll cover how to solve systems using inverses. And even out of those two, our RREF, reduced row epsilon form, which we learned in August, is really the best way or easiest way to solve a system. Well, your homework assignment, it is 2 through 12. Yes?
This would be right? Those are
So this here is A2 by 2. This is A2 by...
Oh yeah, okay, I remember that.
Mhm.
Okay, thank
Yep,
you.
you're welcome. Yes.